All right, this is going to be page 1 of notes 15 of Calc C, and we're going to talk about integration by trig substitution. So this is not a topic that's a part of AP Calculus, but I think it's a topic that should be a part of learning calculus because it just gives you another way that you can deal with integrals that you kind of like run into. So most of these integrals are going to involve radicals, and radicals are kind of the worst. And so let's see what we can do with these. So these are 3 that we can actually do. We don't need to learn anything necessarily to do them. We could do u-substitution, or like maybe I'll show some work. 5 minus 4x cubed. So then du is going to be negative 12x squared dx. So like, I don't know, I like to do this. 1/12 is x squared dx. Make all my substitutions. I'll get negative 1/12, and then I just have u to the 1/2 du. So then plus 1 times the reciprocal. I don't actually, so that's 3/2, so 2/3, negative 2/36, negative 1/18 u to the 3/2, but let's do 5 minus 4x cubed to the 3/2 plus c. First problem of the day, kind of struggling with it. All right, I think that's right. So that's just substitution. Here's another one where u-substitution will work, I think. So if I let u equal 1 plus x squared, then there should be a 2 here, which we balance with a 1/2. And then it's u to the negative 1/2, so plus 1 times the reciprocal. So this is going to give me just 1 plus x squared plus c. Did I forget plus? No. I didn't remember saying plus c, so I thought maybe I'd forgotten it. Another one, pretty straightforward. So this one's in the denominator, this one's in the numerator, but like, no big deal. Same difference. This one, on the other hand, is a problem if you don't remember it, right? So this, it's like if you try to make u equal 4 minus x squared, 4 minus 9x squared, then du has a dx. Du has an x in it, and we don't have an x, and you can't multiply one in, so that's not right. But we know that when that happens, this is actually arc signs somehow, so let's rearrange. I'm going to make this dx over 2. So I'm taking 4 out of everything in the radical, and then the square root of 4 is 2, so that's where that came from. This will be 1 minus 9x squared over 4, which again you might rewrite, and maybe I should have to begin with, as this. It's going to be 1 minus the quantity, 3x over 2 squared. So if I make u equal 3x over 2, then there should be a 3/2 up here, so a 2/3. Let me move this. A 2/3. And this will just be, so the 2's cancel, we get 1/3 inverse sine of 3x over 2 plus c. Let's check these on a calculator because I'm feeling not super confident. And then if I get them wrong, I guess I'll be doing them again. Integral x squared square root 5 minus 4x cubed, comma x. Okay, got it. That was the one I was the least confident on, so maybe this went well. X over the square root of 1 plus x squared, comma x. Got it. And then integral of 1 over the square root of 4 minus 9x squared. So I always type integral. You should definitely use the template. It's like way faster. So we get this. All right, we got them all right. Now, 2 of them were just, I don't want to say basic, but they were just basically u-substitution problems. And then the third one, there was an issue because if you didn't recognize it as being famous, there's like nothing we currently know how to do. What we want to do is learn a way to solve that in the event that we don't recognize it. And it's kind of a really interesting thing. So actually, maybe I'll keep going here. I don't really know. You know what? I'm just going to leave it. I'll leave it there and I'll come back in the next video and I will talk more about it. But like, how are we going to deal with things that look like this? Weird radicals where u-substitution isn't immediately the thing to do. That's our goal. So I'll be back in the next video to do that. See you then.